So section 5.1 is on monomials. Okay, so mono, what does mono mean? One, right. So monomial is an expression that is a number variable or the product of a number or more than one variables. It's only one term. So there's not like, 2x plus 7. That's two terms. It would just be like 2x squared y. That would all be together. That'd be a monomial. Okay, so different types of monomials, like I just said. So like 2x squared y would work. You could have 3/4 x to the 5th y to the 7th z. That works. It's all one term. It's all together. Things that would not be monomials are ones that have variables in the denominator. So notice this one had a denominator, but it wasn't a variable there. It was a number. Okay, so if I had something like x over y squared, that's not a monomial because we don't put our variables in the denominator. Variables with negative exponents, so something like x to the -2 would not be a monomial. And variables under radicals, so we wouldn't say like the cube root of x or the square root of x squared y to the 5th. That would not be a monomial. Okay, constants are monomials with no variables. So constants are just plain numbers. So like 7, 1/2. A coefficient is the numerical factor of the monomial, so it's the number in front. So if I had what I had above, 2x squared y, 2 would be the coefficient, or 3/4 on the next one. Those are coefficients. And the degree is the sum of the exponents of the variables. Okay, so this is important. This is only for a monomial. When we get to polynomials later, it's just going to be the largest exponent. So we're going to add each individual. So like on number 3, see how I have 5, a to the 3rd, b to the 6th. We add those numbers. So it'd be 3 plus 6. Okay, so on number 1, my degree is going to be 6 because it's x to the 6th. Number 2, what's my degree for number 2? There isn't a degree? So it's not 1, it's 0 because it's like there's no x's, it's x to the 0. So there's 0 for the degree. Number 3 is what I told you, you add the degrees, so 3 plus 6 equals 9. Number 4 would be 2 plus 6 plus 2, so it's 10. And number 5 would be 2 plus 3 plus 9, so 14. So how do I get a degree of 1? So we said number 2 is a degree of 0. How do I get a degree of 1?
X.
Yeah, if you just had like x or y, right? That'd be like x to the 1st power. All right, so a power is an expression of the form x to the n. Oops, I left off my little n here. Or 1, 2, 3, 4, 5, 6, 7. It should be 7 there. So write 4 to the 7th. Okay, 4 is called my base. 7 is called my exponent. The whole expression is called a power. Okay, even I mess this one up, I always say 4 to the 7th power. You should really say 4 to the 7th is the whole power. All right, when we see 4 times 4 times 4 times 4, etc., that's called expanded form. Okay. So these next 3 expressions are different. So they have different values. So when I see -2 x to the 4th, the only thing that is being raised to the 4th power is what? X. That's the only thing. So my base is x. So it's whatever's being raised to the power, or raised to the exponent. So my expanded form would be -2 would just be out front by itself, and then I have 4 x's multiplied by each other. That would be expanded form. Okay, now the next one's different. What's the base in this case? 2x. That's what's being raised to the 4th power. So in this case, the negative is out front, and you have 2x multiplied by itself 4 times. Okay, and on the last one, do you guys see the base is negative 2x? So in this case, the whole negative 2x is being raised to the 4th. So it's going to be multiplied 4 times. So if I ask the value on each of these things, this first one was negative 2x to the 4th, just the way it's written in the beginning. The next one would be negative out front, and then 2x times 2x times 2x times 2x, so 16x to the 4th. And the last one would be negative, 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 so that'd be positive. So it's positive 16x to the 4th. So see how all 3 of those things are different. Okay, so number 1, so write each expression using exponents. So these should be pretty easy for you. So number 1a is just going to be 3 raised to the 4th power. B is 5 to the 3rd. You have 3 of the 5s. I have 5 x's, so x to the 5th. This one's going to be 2 squared, 5 to the 3rd. And the last one's negative 3 squared times 2 to the 3rd. Okay, do those all make sense to you? Okay, these ones are the ones that are a little bit harder for people. Okay, so, yeah. Is it a what sign? Yeah, that's a times, yeah, not a minus. My times looks like minuses sometimes. You could put it there too, doesn't matter. You don't need them at all. All right, 2a, so I have 2 to the 5th, so write it in expanded form, so that'd be 2 times itself 5 times. So it'd be 4 times 4, which is 16 times 2, so it's 32. Next one, negative 2 to the 3rd, so negative 2 times negative 2 times negative 2. So that's negative 8. How about C, what would it be? 16? No, not 16. C? So only the 2's being raised to the 4th, so it's a negative out front, and then 2 times 2 times 2 times 2. So it's negative 16. All right, D, so I have 1/2 x to the 4th, so it's going to be 1/2 x times 1/2 x 4 times. Okay, so think about 1/2 times itself 4 times. What would that be? On the top, I'd have 1, right? 1 times 1 times 1 times 1. On the bottom, I'd have 2 times 2 times 2 times 2. So 1 over 16, right? X to the 4th. Okay, and the next one, I have negative 1/3 x times itself. So I get 1/9 x squared. Okay, and the next one, I'm going to have negative 2 times a times a times a times b times negative 5 times a times b times b times b times b. So that's the expanded form. So what's the number out front? You guys are sleepy today. Negative 2 times negative 5. Do you guys see it? 10. Okay, so we multiplied the numbers out front. Now how many a's do I have? So I have 1, 2, 3, and then another one, 4. So a to the 4th. And then I have 1, 2, 3, 4, 5 b's, so b to the 5th. So 10, a to the 4th, b to the 5th. Go back. All right, so the zero exponent property. So it's a non-zero quantity raised to the 0 power is equal to 1. Okay, so basically if I had like x to the 0, that's 1. Okay. So 5 to the 0 is 1. Okay, so we'll talk about why that is in just a little bit. Negative exponent property. So negative exponent, so if I have x to the -2, it's equal to the reciprocal of the base raised to the positive exponent. So reciprocal of the base means 1 over x, and it'd be raised to the +2. In other words, it's 1 over x squared. So I just remember if I have a negative exponent, I just do 1 over the positive exponent. Okay, if I see it as 1 over x to the -3, it can be kind of messy. I'll write it down here. If I had 1 over x to the -3, that's 1 over x to the 3rd, like that. Because an x to the -3 means 1 over x cubed. So that's 1 divided by 1 over x cubed. What do I do when I divide by a fraction? Right, multiply by the reciprocal. So it's 1 times x cubed over 1. So it's just x cubed. So if I see 1 over x to the -3, I just write it as x to the 3rd. So it's still, you just take the reciprocal and raise it to the positive. Did you see how that works? So I always remember if something's on the bottom and it's negative, I bring it to the top and I make it positive. Okay, so let's do this chart. So I have 2 to the 3rd is 8, 2 to the 2nd is 4, 2 to the 1st is 2. What am I doing each time to get to the next number? So how are 8 and 4 related? Yeah, you divide by 2. Okay, let's see if that pattern holds. So 2 to the 0 is 1, so that worked. I divided by 2. 2 to the -1, I said that's 1 over 2 to the +1, so that's 1/2, so I still divided by 2. 2 to the -2 is 1 over 2 to the +2, so that's 1/4. The next one's 1/8 and 1/16. Each time you're just dividing by 2. So question number 1, do negative exponents mean that the number is negative? No, so look at your negative exponents. So all of these had negative exponents, but my number wasn't negative in the end. It was 1/2, 1/4, 1/8, 1/16. So no. So it means take the reciprocal to the positive exponent. What is any number raised to the 0 power? 1. It's not 0. And what do you notice about 2 to the 3rd and 2 to the -3? They're reciprocals, right? Okay, so let's try these examples. Now you need to let me know if you're not understanding these because a lot of times this homework assignment is difficult for people. So let me know right away if you don't understand. So if I have 4 to the -3, remember that's going to be the reciprocal, so it's going to be 1 over 4 to the +3. Think about 4 times 4 times 4. 4 times 4 is 16. If you do 16 times 4, that's 64. So it's 1 over 64. So even though it had a negative exponent, my number was not negative in the end. It was just a tiny little fraction. Okay, x to the -2. This is a big one. I do this all the time in AP Calculus, and some people always forget it. So you need to know this for the rest of your math classes. So x to the -2. How do I simplify that? what was it?
1 over x squared.
Right, you need to know that. So 1 over x squared. So a lot of times your instructions will say, make sure there are no negative exponents in your answer. Okay, so that would be a way to get rid of a negative exponent. Write it as 1 over x to the positive 2. Okay, this one's a little tricky, so I have 1/2 to the negative 2. So you can do this a couple different ways. You can think of this as 1 over 1/2 to the positive 2, right? Because a negative exponent means 1 over, which would be 1 over 1/4, which is 1 divided by 1/4. So 1 times 4 over 1, so you get 4. Okay, that's a lot of steps though. So remember how my negative exponent property, how it was phrased. It says a non-zero base raised to a negative exponent is equal to the reciprocal of the base raised to the positive exponent. So that means we could have started up here. You don't have to erase if you had what I had. And you could just take the reciprocal of the base. So instead of 1/2, I could do 2 raised to the positive exponent. So 2 to the 2, which is 4. Okay, so either way you get the same thing. Okay, how about number 4?
1.
It's 1, good. I do that a lot on extra credit problems, where I'll have like a big mess, and then times another big mess, and then times another big mess raised to the 0, so you can just get rid of one of them. Like anything raised to the 0 is going to be 1. Okay, so like 5, I have 2x times something raised to the 0. So that means this whole second part is 1, but I still have that 2x out front. So don't forget you have 2x times 1. So your answer is just 2x. So see how the 2x wasn't raised to the 0? So you couldn't just get rid of that. All right, next up. Okay, product of powers property. All right, you don't have to know what all these names are, by the way. You can just use these. So product of powers, to multiply the powers with the same base, add the exponents. Okay, so if I have x to the 2nd times x to the 5th, it's going to be x to the 7th. Okay, that's what that's saying. Think of it in expanded form. If I had x to the 2nd, it'd be x times x. X to the 5th is 5 of them. So how many total do you have? 7. X to the 7th. Makes sense? Okay, so written out with variables, if I had x to the a times x to the b, it's x to the a plus b. Sorry. So x to the a times x to the b equals x to the a plus b. Ran off a little bit. Okay, quotient of powers. Okay, if I have x to the 8th over x to the 2nd, a lot of people say that that's x to the 4th. They just do 8 divided by 2. But think of it in expanded form. If I had 8 x's on top and 2 on bottom, if I have something in common on the top and the bottom, like if I had 2 over 2, 2 over 2 would reduce, right? So x over x reduces. X over x reduces. How many would I have left? 6. So you subtract your exponents. So it's x to the 6th. So if I have x to the m over x to the n, it's x to the m minus n. That's an n down there. So x to the m over x to the n equals x to the m minus n. Okay, power over power. So to raise one power to another, multiply the exponents. So if I have x to the 2nd raised to the 3rd, like that. Again, I always had to think of it in expanded form. So when I was your age, I thought, okay, I have x squared times itself 3 times. So I thought, okay, x squared times x squared times x squared. And I thought, okay, well that's 1, 2, 3, 4, 5, 6. It's x to the 6th. So you multiply your exponents. So if I have x to the a raised to the b, it's x to the a times b. Okay, power of a product. So if I had x to the 2nd times x to the 5th, all raised to the third. So apply the exponent to each factor. So what do you guys think that would be? Kind of tricky here. Maybe I should make it y on the second one. Let's make this y to the fifth. Okay, so what would you do? Yep, x to the sixth, y to the 15th. So it goes in each one.
If it was x and x, after you like multiply 3 times 2 and then 3 times 5, would you add?
Yep. Yeah, or you could add first, add the exponents, and then multiply by the 3. So either way.
Okay.
All right, and then power of a quotient. So let's say I have x to the fifth over y to the third, and I'm raising it to the second. Then that 2 just goes into both pieces, because it's like you're thinking of x to the fifth over y to the third times itself one time. Well, 2 times squared. So there's 2 of them. So you add your powers here, add your powers here. So it's going to be x to the 10th over y to the 6th. So you just brought that 2 into both pieces. Okay. So you guys try 1, 2, and 3. So think about 1, 2, and 3, what they would be. All right, so Andrew, what'd you get for number 1?
Is that 5, 7?
5 to the 7th. Right, 5 to the 7th. A lot of people will say 25 to the 7th. So think about it in expanded form. It's 5 times 5 times 5 times 5 times 5 times 5 times 5. So there's 7 5s. So 5 to the 7th. Okay, Taylor, what'd you get for the next one?
5x to the 6th, y to the 4th.
Exactly. Did you guys all get 5x to the 6th, y to the 4th? So your x cubed times x cubed would give you 6 x's in a row. So x to the 6th. Then you have 5 out front and y to the 4th. All right, Kern, you got the next one? X, y to the 7th. Perfect. So you're thinking of the x cubed on top and the x squared. So x cubed on top, x squared on the bottom. This is what you're doing in your head. You're saying, okay, one of those is canceling with the other one, another one cancels with the other one, you have 1 left. Or you could just use your subtraction rule, right? So 3 minus 2 gives you 1 left. Yeah, Gabby?
Okay, in the like power of a product and power of a quotient property, why is in like the first one, why is it 6 not 8?
On
You're applying the exponent to the
that, like 2 and 3?
Yeah.
Because 2 times 3 would be 6 then.
Yeah, but oh, okay.
Okay, next up. Or are you thinking 2 raised to the 3rd power?
Yeah.
Okay, so let's try some of these. So number 4, so I should have x to the 2nd raised to the 4th times y to the 3rd raised to the 4th, right? You bring the 4th into each piece. Or you could just do that all in one step and say it's x to the 8th, y to the 12th. So multiply your powers. Okay, now on this one you can do a couple different ways. You can bring the 4 into each piece and then simplify, or you can simplify the inside part and then raise it to the 4th. So I'd probably simplify the inside part. Okay, so if I have x over x squared. Okay, one reason I don't really like using the subtraction rule necessarily, like x to the first minus, so x to the 1 minus 2 is what you'd get, like x to the first over x squared, x to the 1 minus 2, is because you'd get x to the negative 1, and then you're left with negatives, which are kind of hard to deal with sometimes. So think about, how I was talking about with the canceling. So you have 1x on top and 2 x's on bottom. So how many would cancel? 1 on the top and the bottom, right? Where would 1 be left? On the bottom. So that means that I'm going to have over x y's are just still on top, and the z is still on the bottom, it's going to be raised to the fourth. Do you guys all understand that? Okay, now bring the fourth power in. So I get y to the eighth over x to the fourth, z to the fourth, and that's your answer. You can't like reduce down the powers. Like some people will try to say like 8 and 4 reduced to 2 and 1. You can't do that. All right, so this next one I see I have it to the negative third power. So I could do 1 over all of that to the positive third. But the easiest thing to think of is just take the reciprocal of the base. And raise it to the positive third base. So I'd have y over 2x raised to the positive third. So I took the reciprocal of the base and raised it to the positive power. Okay, now be careful here. Bring the third in. So I know I'd have the y to the third, and on the bottom I'd have x to the third. But is it just 2? Do I leave it just as 2 on the bottom? Nope, the third goes into it as well. So it goes to all 3 pieces. So I'm going to have 2 to the third. So what is 2 to the third? 8, right? So I'm going to have y to the third over 8x cubed. So y to the third over 8x cubed. All right, you guys try 7, 8, 9. So try 7, 8, 9. Okay, so if you see a negative exponent, the easiest thing to do to get rid of it, if it's already a fraction, is just take the reciprocal of the whole base. So do that first. So I would get b squared on top over 3ab, and I'm going to raise it to the positive 2. Now you could also bring the negative power in each thing, and then think of those as all as 1 over, 1 over, 1 over. But that's really the easiest thing to do if it's already a fraction. Just take the reciprocal of the whole base and raise it to the positive power. Okay, now let's simplify the inside part first. So when I see b squared and b, I'm thinking of it as 2 b's on top, so b times b all over b. So one of them would cancel on the top and the bottom. Or you can use your subtraction rule. B to the 2 minus 1 would be b to the 1. Okay, that goes on top. Over 3a squared. Now bring the 2 into each piece. So I'd have b squared and I'd have a squared. And what's my number? No, not 6. 9, right? 3 squared. Okay, so 2 and 3, so it'd be 3 to the second. So notice you're not multiplying the numbers, you are only multiplying exponents. So it's still 3 to the second power. All right. So this next one looks a little scary. Okay, so let's go one thing at a time. So let's look at the numbers. I have 5 and I have 15. Well, how do I reduce the fraction 5 over 15? 1/3. So just like before, it still reduces 1 over 3. Okay, now let's look at the x's. On the top, I have x cubed x to the 5th. So I'd add my exponents and get x squared. On the bottom, I have x to the 0. So that's just gone. So you can just ignore the x to the 0. So I end up with x squared on top. Now my next ones, I have y cubed over y to the negative 2. Okay, you can do your subtraction rule. It'd be y to the 3 minus a negative 2. You'd end up with y to the 5th. Do you guys see that it would be y to the 5th? Okay, another way you can think of it is if you have anything to the negative power, just bring it to the opposite location and make it positive. So on the top, I'd have y cubed and y squared. So it'd be y to the 5th. Okay, do you want me to rewrite? Okay, let me try this another way, because these get confusing. Okay, so let's start it out. Let's get rid of the x to the 0, because that's just 1. Okay, and anything with a negative power, I'm going to take to the opposite location. So I had x to the negative 3 first. on top. So it's going to be x to the positive 3 on bottom. So I'm going to have 5, x to the positive 3. X to the 5th stays where it is, y to the 3rd stays where it is, 15 stays where it is, and y to the negative 2 now goes on the top and becomes y to the positive 2. Okay, so you could rearrange like that to begin with. Like we said, 5 and 15 cancel and become 1 over 3. Now I'd have x squared and y to the 5th. So you should end up with x squared y to the 5th all over 3. That should be your answer. Okay, how many of you guys got that? It's a hard one. I need to do what? Oh, the 2 on the outside, okay. Yeah, I forgot. So all of that's being squared, isn't it? Oops. So it should be x to the 4th, y to the 10th over 9. Okay, so how many of you guys got that? Anybody? Chris? Kendall? No one else? Okay, it's a tough one. Okay, so now let's try number 9. So let's do that trick where we move things around to begin with. So anything that's negative, we can move to the opposite location. Or you could just use your subtraction rule. Just know if you get a negative out, it goes on the bottom and becomes positive. So see how you could do the subtraction rule? You'd have negative 6 minus a negative 5. So I had negative 6 plus 5, which is negative 1. So if I had a to the negative 1, where would it really be? You can see it would be on the bottom as a to the positive 1. Okay, that's why it gets a little confusing when you use the subtraction rule, because it's like if you get a negative out, you still have to put it in the opposite location. So I usually like to switch places first. So I have 36 over 4. My a to the negative 6 was negative, so it's going to go to the on the bottom and become positive. B to the negative 5 was negative. It's going to go to the bottom and become positive. C to the 3rd was already positive, so it stays on top. Okay, other things that are negative, my a to the negative 5, so that's going to go to the top and become a to the 5th. B to the negative 3 is going to go to the top and become b to the 3rd. It's all raised to the negative 2. Okay, I'm almost done. Yeah. Oh, is it 45? Okay, I'm blind. 45. Okay, so now let's reduce. So 36 and 45, what do they have in common? 9. So divide by 9 on the top and bottom. So I'd have 4 over 5. How about the a's? So I have a to the 5th, a to the 6th. So that's a on bottom, just a to the 1. I have b to the 3rd on top, b to the 5th on bottom, so it's b squared on bottom. C cubed, and it's raised to the negative 2. So since it's to the negative power, now let's flip everything. I'm almost done. And raise it to the positive 2. So your final answer should be 25, a to the 2nd, b to the 4th, over 16, c to the 6th. Tough one. Tough one.